In this next section, we're going to look at higher order derivatives. Okay. A higher order derivative is just what it sounds like. I'm going to take a derivative in order to get another derivative. And I'm going to go higher up for the number of derivatives that I want. Okay. If we think back to our notation f prime of x or dy dx, this is said to be just the first derivative of x. Up till now we've just said it's the derivative, but it's the first derivative that we're taking. Following that notation, f double prime or d squared y dx squared is the second derivative. And I actually write it this way because I do actually mean what it's saying. I'm starting with dy dx, and I'm going to take the derivative of this with respect to x. So I'm squaring the d's, or taking the second derivative of y, both with respect to x. Okay? That's what d squared y dx squared means. Okay? Likewise, the third derivative of f is going to be f triple prime, or d cubed y dx cubed. Okay? We can follow this pattern on for as far as we want to go. And in general, we say f to the n, or the nth derivative, ny squared dx to the n, is the nth derivative of f for any particular function. Okay? Now the notation can get a little crazy. Not so much now, but definitely later on. And again, all this is saying is I'm going to take the derivative of a derivative in order to get the next order. Okay? So to find a higher order derivative, we simply take another derivative of the function. So let's look at this one for example. F of x equals 5x to the fourth minus 3x squared plus 2. We want to find the third derivative. Okay? Now I'm saying derivative a lot, but again, all it is taking another derivative of a derivative and so forth. Okay? So here, I'm always going to start with my first derivative. So, if f is this, I can use my properties to get f prime. F prime is going to look like 20x cubed minus 6x plus 0. To get my second derivative, I'm derivating that function. So I'm going to take this function and take its derivative. Well, again, I can apply my power property. So bringing the power down, it looks like 60x squared minus 6. And then to get my third derivative, so I'm going to take the second derivative and take the derivative of that. Again, applying my power property tells me it's just 120x. Okay. Many of our functions we can keep going, and so you may be asked to find 5th or 6th or even 10th or 12th derivatives. And most of them are this straightforward. Not all of them are this nice. So for example, let's look at f of x equaling 3 plus 2x over x plus 1. And let's just go to the second derivative. Well, in this case, because it's not a polynomial function, I have to use my quotient rule. Again, I'm going to start with just f prime. So looking at my first derivative, it says it's the derivative of the top times the bottom minus the top times my derivative of the bottom, all divided by the bottom squared. Okay. Now, unlike the last example, I didn't really need to simplify before I moved on, because the power property, not too hard to do that all at once. Here, I'm definitely going to want to simplify this before I take a derivative again, because now I'm going to be taking a derivative of this function. And so I definitely want to clean up that as much as I can. So here we can see 2x plus 2 minus the 3 minus 2x all over x plus 1 squared Canceling our two x's, we get a negative 1 over x plus 1, the quantity squared. Okay. With that as our first derivative, we can now find our second derivative. And again, it just means I'm using this as my function and I'm going to take the derivative. So the derivative of the top times the bottom minus the top times the derivative of the bottom. Don't forget that chain rule. All over bottom squared. Okay. Again, clean up where you can. Even though I'm not taking another derivative, I should still simplify my answer. So notice this first term goes to 0, so that's just going to go away. And I'm left with a 2x plus 1 over x plus 1 to the 4th, which we can see simplifies to 2 over x plus 1 cubed. There's our second derivative. And that's it. Again, you're going to have some functions that are fairly straightforward, like your polynomials. There are going to be some that are going to be a little bit more complicated. But in order to find a higher order derivative, all we're doing is taking the derivative of a function.